Okay, this is on section 1.2 on the graphs of equations. So we're kind of going back to the beginning of algebra and reminding you the process that we use to sketch up the graph of any equation. So you always want to isolate one of the variables. Most of the times we're going to isolate the y in the equation. Then we're going to make a table of values showing solutions. So we're going to plug in numbers for x, and then we'll simplify and get a value for y. Then we will plot those solution points. Once you've plotted the points, we'll connect the dots for a curve or a line, whatever the graph makes. Okay, so graphical tests for symmetry. So symmetry is when two sides of a graph or of anything match up if you fold it along the x-axis, the y-axis, or the origin. So the way that we know that something is symmetric is by looking at these tests. So for x-axis symmetry, the solutions x, y, and x negative y are solutions. So y values will be opposite, but there will be two of them. So the same x value will give you a positive and a negative y value. Y-axis symmetry, the points xy and negative xy are solutions. So if you plug in two opposite x values and they give you the same y value, then that's y-axis symmetry. And then origin symmetry is when xy and negative x, negative y are solutions. So the same point, same ordered pair, but opposite signs. Next, the intercepts of a graph. So the y-intercept is when you plug in 0 for x and solve for y. And you're going to get an ordered pair that is 0, comma, some y value. The x-intercept, you're going to plug in 0 for y and solve for x. So we have x, comma, 0. The equation of a circle is x minus h all squared plus y minus k all squared equals r squared, where hk is the center of the circle and r is the radius. So let's look at a few examples using this information. So let's start by graphing the equation y equals x squared minus 3x. So I'm going to start with a table, and I'm going to plug in values of x into the equation, simplify, and get a value for y. Then I'll plot those points. So I'm going to start with negative 2. So negative 2 squared minus 3 times negative 2 is 10. I'm going to do negative 1. Negative 1 squared minus 3 times negative 1 is 4. 0 squared minus 3 times 0 is 0. 1 squared minus 3 times 1 is negative 2. And 2 squared minus 3 times 2 is negative 2. So we're going to plot these points and see what we can get from the graph. If I need to add some more points, then I will. So negative 2, 10, negative 1, 4, 0, 0, 1, negative 2, and 2, negative 2. So as is, these points don't tell me a whole lot about the graph. I don't know what's happening on the right-hand side of 2. Does it go straight? Does it go down? Does it come back up? So I'm going to pick a few more points to plug in. So if I plug in positive 3, 3 squared minus 3 times 3 is 0. And then let's do one more. So 4 squared minus 3 times 4 is 4. So if I add these points to the graph, now I can see that this is the shape of a parabola. Okay, on number 2, we're going to find the x and y intercepts. So y squared equals 6 minus x. So I'm going to get y by itself first. So to get rid of the square, I need to take the square root of both sides. So when we find the x-intercept, we're going to plug in 0 for y first. So I'm going to do, instead of going ahead and get y by itself, we'll just plug it in as is. So 0 squared equals 6 minus x is 0 equals 6 minus x. Then to get x by itself, I would just add x to both sides. So x equals 6. So my x-intercept is 6, comma 0. Now for the y-intercept, I'm going to plug in 0 for x. So y squared equals 6 minus 0, which y squared equals 6. So now to get y by itself, I take the square root. So remember, anytime you take the square root of a number, it's the positive and negative square root. So y equals positive and negative square root of 6, which will give us 2 y-intercepts. 0 square root of 6 and 0 negative square root of 6. So I actually have 2 y-intercepts. Okay, so now we're going to determine what type of symmetry this graph has. X minus y squared equals 0. So what I want to do is get y by itself. So I'm going to move the y squared to the other side by adding y squared. So that means x equals y squared. I want to get rid of the square, so I'm going to take the square root of both sides. And remember, when you take the square root, it's positive and negative. So y is the positive and negative square root of x. So I'm going to make a table of values, and so I can determine what type of symmetry this graph has. So let's think about this. If I plugged in a negative number, I can't take the square root of a negative number. We haven't talked about imaginary numbers yet. So we're going to skip over the negatives in my list. Then if I did 0, the square root of 0 is just 0, so that doesn't help me either. So let's start with positive 1. So if I plug in 1 for x, and I have the positive and negative square root of 1, square root of 1 is 1, so it's going to give me positive 1 and negative 1. Same thing when I plug in 2. It's going to be the positive and negative square root of 2, so that's 2 solutions. So the square root of 2 and the negative square root of 2. So I have an x value that it's giving me 2 different y values. So that means that this graph is symmetric to the x-axis. Okay, so just make a table of values and then you check the rules to see what it's symmetric to. If it doesn't follow any of the 3 rules, then it's not symmetric to anything. You can also look at the graph in your calculator. If I type this in, I would actually have to do it in 2 separate equations. Y equals the positive square root of x and y equals the negative square root of x. And then we could see that it would be symmetric, or it would reflect across the x-axis. Okay, number 4 wants us to write the equation of the circle, and it gives us the endpoints of the diameter. So I need the center and I need the radius to write the equation. So to get the radius, then I'm going to find the distance between these 2 points, which is the diameter, and I'm going to divide by 2. So the diameter is going to be the square root of 0 minus 6 squared plus 0 minus 8 squared. And we're going to divide by 2 because I need radius and not the diameter. So this is going to be the square root of 36 plus 64 all over 2. 36 plus 64 is 100, and I know that the square root of 100 is 10. 10 divided by 2 is 5. So the radius of the circle is 5. Now we need to find the center of the circle. So the center is actually going to be the exact middle point of these 2 endpoints of the diameter. So that's the midpoint. So it's like an average of the 2 points. We're going to do 0 plus 6 divided by 2, 0 plus 8 divided by 2. So the center, or the midpoint of this diameter, is going to be the point 3, 4. So now I'm going to plug in the radius and the center into the equation of a circle. So x minus h all squared plus y minus k all squared equals r squared. So we just plug it in. X minus 3 all squared plus y minus 4 all squared equals 5 squared. Now the only thing that you need to simplify here is if you have double negatives in the parentheses, we would go ahead and change those to positives. And if you have a number at the end that is squared, go ahead and square it. So the only thing we're going to simplify on this one is change the 5 squared to a 25 on the end. So this is the equation of this circle.